Hello. Here, we will discuss about the nature of sound. Sound waves are longitudinal waves produced by a vibrating source. The vibrating sources can be guitar strings, or tuning forks, or a loudspeaker. The longitudinal waves vibrate molecules of the medium in the direction of propagation. So, if a sound wave is moving in X direction, then the molecules in the medium will get compressed and expanded in the same direction as that of the propagation of the wave, in this case, X direction. As you can see in the diagram, the vibration produced by the source creates a series of compressions and rarefactions of particles in the surrounding medium. Now, the important thing to note down here is that molecules themselves do not move from one position to another position permanently. In this case, the molecules only vibrate. They either get compressed or expand. So the mean position of the molecules remains the same. When we speak, the vibrations in our voice box, which is known as the larynx, produce a series of compressions and rarefactions of air particles in the surrounding medium. As you can see in the diagram, the compressions explain that the molecules are compressing on each other, which means the area of compressions results in a higher density of molecules. So compressions represent more number of molecules in that region. However, rarefactions mean the molecules are going away from each other. So the density of molecules in the region of rarefaction is lower. So when a sound wave propagates through the medium, it creates compressions and rarefactions. At compressions, as it has a higher density, it also creates higher pressure. On the other hand, rarefactions, as they have a lower density, will result in creating a lower air pressure. By measuring the air pressures at different points in the room, we can trace out the following diagram. This diagram is known as a wave diagram. The diagram is drawn considering the air pressure and the distance from the source. In the region of compression, there will be a higher air pressure, higher density, and so will be the amplitude of the wave or the loudness of the sound. On the other hand, in the regions of rarefaction, the density of molecules is lower, so the surrounding air pressure will be lower, and the loudness will be lesser. Hence the amplitude is lower. As we have seen that the sound wave is a longitudinal wave, and it is propagated through the medium by vibrations of molecules or atoms in that medium. So for propagation of a sound wave, a medium full of molecules or atoms is required. In vacuum, there are no molecules or atoms, so sound waves cannot propagate or travel through vacuum.